So if you wanted to take features in this model and match them up to what you see throughout this landscape, you'd end up with something like this, where this outermost little anticline that's on this very shallow splay thrust fault would correspond to these subtle ridges. You're not in the right part of the wedge here to really see a lot of topographic prominence or extreme relief, but the structural control on landscape is visible there in the parallelism of the ridges. The valley developed in that deep carbonate material in the hanging wall of this big frontal thrust fault would correspond to this valley. And this entire large topographic zone, with our dominating synclines in the middle of it, corresponds to this entire part of the wedge where you see this lower wavelength folding within that very tough and resistant sandstone layer that is about mid-level in the stratigraphy. And the reason you can get this smaller scale folding is that there's a little bit of slip and detachment in this layer, there's a little bit of slip and detachment in this purple sand layer, and that allows structures at a small wavelength to form that are going to look a little bit different from these much larger wavelength structures that are associated with thrust faults carrying the entire stratigraphic section here. And of course, within that mass where that syncline is present, that's where you're going to find those small plateaus that, despite being sort of flat and rolling at their surface, are going to be the absolute high points in this landscape. In the hanging wall of this major thrust further towards the hinterland, this erodible rock's available at the surface, that's going to make a big broad valley. On the back limb of that structure, you'll find that ridge forming sequence one last time. That's going to give you these ridges here. And at this point, everything off to the southeast is sort of off the model. That's a little bit deeper into the Appalachian orogenic wedge, and you're actually looking at the edge of the crystalline thrust sheets here. So that's not shown in the model, but certainly the topographic style that you see here corresponds to the structural style, and high points versus low points has everything to do with the stratigraphy present here and the style of folding and the arrangement of those folds, and particularly where that resistant rock is preserved in the wedge by synclines adjacent to areas where it's already been eroded away on top of these big anticlines. So you can see this also in bedrock geology. This is just a Google Earth geologic overlay. The blue units here are stratigraphically deeper. This sort of lighter gray-green color is higher section material, and indeed that higher section area where the tough resistant sandstone is preserved and our little syncline is very apparent. The blues next to it associate with these deeper carbonate units, so even though this is a structural low, it's a topographic high. Right? And if you look at this area within the scope of the entire Appalachians, you can see that to the northeast, the fold thrust belt is much broader. You don't see particularly broad agricultural valleys in it, and there are a lot of ridges. There's literally dozens of ridges. That associates with a structural style like you see here. There are several thrust faults. They have very little displacement, and that ridge-forming topographic unit stays at about the same structural level the whole time. So it's really not possible to get deep into one of these valley-forming lithologic units and preserve really high topography next to it. It's just not in the structural style. Come down here to the southwest, you have these really high displacement thrust faults. In this location, it's very possible to have the land surface stranded at high elevation in one of these synclines while it's carved a much deeper valley into that deep section erodible rock next to it. And you can actually see that from this Google Earth perspective, where you've got broad valleys, prominent ridges, and then more broad valleys. So even though there are fewer ridges, the topographic prominence is greater, and that has everything to do with the structural style. The stratigraphy is not too much different between these two regions. You're essentially looking at the same sequence of rocks, and they have the same mechanical properties. It's just the way they are deformed is significantly different, and that has a very strong impact on topography. So you have to keep in mind that what you're looking at here is an expression of structure and how the structure impacts the stratigraphy. And I'm going to talk in a follow-up video here a little bit more about the actual mechanics of how a syncline like this can sort of lag behind erosionally in the landscape and produce the topographic high points that we see actually throughout the deeply eroded Appalachian fold thrust belt.